Hello again, and now we are starting a new chapter, and we'll still be talking about linear lines and linear functions and functions in general. We want to give them a little practical applications on this and how we can use them to model stuff. So this is a problem that's similar to what you'll be seeing in the homework for this section, Section 2.1. And this is an attempt to take the number of classified documents that the government classifies each year as a function of time, but particularly it says the number of classified documents has increased approximately linearly from 8.5 million documents in 2001 to 18.9 million documents in 2005. Let n be the number of documents in the millions labeled as classified in the year that is t years after 2000. And we are going to try to write n as a linear function of t. Now the reason why we're letting t, so we say t years after 2000, is because if we just let t be the year, that will be kind of, and we look at the attempt to look at the line, it's going to be kind of it'll be a little hard because all the data points will be over a very small interval on the x-axis. Okay, so we're just going to, so that's why we make this adjustment here. Now, when we want to write n as a linear function of t, we're not saying that they are, that this is actually going to be the formula, because it just says it's approximately linear. So we're going to see what's the best approximation based on the data that we're given. Okay, so here is the, so what we're trying to do is we're trying to write n as a linear function of t. That means n is the dependent variable and t is the independent variable, because n is going to depend on the time. So we want to write n as in the form of mt plus b. Okay, notice this is very similar to writing y. You know, if y is a linear function of x, we would write y equals mx plus b. Okay, but here we're replacing y with n and x with t. Now, what are the data points that we're given? We're given, well, in 2001, that corresponds to t equals 1. And we see that n is 8.5. Okay, 8.5. And remember, n is in millions. And at 2005, we're given that t is equal to 5, and n in that case is 18.9. Right? All right, so we have these 2 points. Now these 2 points are going to correspond to, we want to model n's relationship with t as a line, and this corresponds to 2 points on the line where we have 1, 8.5, and 5, 18.9. Okay. So these 2 points are going to be on the line. Remember, the t is playing the role of x. That's why the t coordinates come first. Okay, and then n is sort of playing the role of y. So these are the values of n. So this is like t and n. All right. Now, finding the equation of the line, we know how to do that. We've done that in the previous chapter. So the way we do this is we first find the slope, and this will be, what will it be? It will be 18.9 minus 8.5, and then the change in the change in the t will be 5 minus 1. Okay, so this will be, this turns out to be 10.4 over 4, and on your calculator you see that this is 2.6. So that's what m is. And then to find what b is, we can just use, pick one of these points and plug this in here. So right now we know that n is equal to 2.6 times t plus b. We plug in t equal 1 and b equal 8.5. Okay, this is 2.6. We subtract 2.6 from both sides. And we get b is this difference, and so b turns out to be 5.9. So we get our n is equal to 2.6 times t plus 5.9. All right. So now let's see if we use this to estimate the number of documents classified in 2003. Well, in 2003, that's 3 years after 2000. So n will be 2.6 times 3 plus 5.9. And this is equal to 13.7. All right. Now, the answer to the question is not 13.7. Remember, n is the number of documents in the millions. So the actual answer would be 13.7 million documents. Okay, so you have to be careful about that. And then we want to estimate the number of documents classified in 2008. Okay, that corresponds to t equals 8. So n is 2.6 times 8 plus 5.9, and that's 26.7. So the answer would be 26.7 million documents. All right. So that is the first example. We'll do another example in the next video.